We'll continue our addition and subtraction of rational expressions. So if you're adding or subtracting, you have to have a common denominator. If your denominators are binomials or trinomials, you have to try to factor them first to see what they're made of. For this problem, the denominators, there's no factoring that we can do. These two factors do not have anything in common, and so we will have to use both of them. So we are going to need an x plus 3 and an x minus 2. So on our first fraction, we're missing the x minus 2. We have to put it on top and bottom. And on the second fraction, it has the x minus 2. We are missing the x plus 3. Put it on numerator and denominator. Now, before we go on, remember that eventually you're just going to keep the common denominator. So there's no reason to multiply out the denominators. We can leave it in factored form. But the numerators combine, so they have to be multiplied out. So we'll go ahead, we'll distribute that 4x to each of those. So we're going to have 4x squared minus 8x, and it's over this denominator. We will distribute the 3. It's a plus 3. You can always take that sign with it to save yourself some time. And so we're going to have 3x plus 9 over this same denominator. And then we're going to keep the denominator and combine the numerators. So we have 4x squared. Our x terms can go together, will give us minus 5x plus 9. You're supposed to try to factor that to see if it will reduce. I tried for a little while, and it does not factor. For our next problem, we look at the denominators. They are binomials, but they will not factor, and they have nothing in common. So for the LCD, we will have to use them both. This means that the first fraction needs an x plus 6. The second fraction will need an x minus 5 to get that common denominator. Right? And so we will keep the denominators. And multiply out the numerators so they can combine. So this is a 2x squared plus 12x. Right, for our next one, if you want, go ahead and take your negative with your 3 when you distribute, or take time to make a step to do that. So that will be a negative 3x plus 15 over this same denominator. Now we will keep the denominator and combine the numerator. So on the numerators, I have a 2x squared. I have 12x minus 3. Different signs, subtract sign of the larger. Would be a 9x plus 15. And we could try, but I did not get this one to factor to reduce. For our next problem, we are going to look for the common denominator. Our denominators do have a common factor, so we're going to build up this LCD. You have to take every type of factor that you have. So we need x minus 6's and x plus 7's. The x minus 6, it only occurs in any one fraction one time, so you will need it just one time. The x plus 7 only occurs in any one fraction once. Once here, none here, so we will need an x plus 7. That will be the common denominator, which means your second fraction is okay. Your first one is just going to need the x plus 7. And I'm going to shorten this step just a little bit. Right? I'm going to go ahead and just keep that common denominator. So I have x plus 7 times x minus 6. And I'm going to combine the numerators on there. So I'm going to distribute. This will give me x plus 7. Right. Over here, I need to make sure I distribute this minus. So we'll get minus 25 plus 2x. Now, I'll combine on the numerator. 2x plus x is 3x. On our constants, different signs, subtract sign of the larger over this denominator. Now, our last step, which we haven't had to do so far, but this problem we're going to need to, we have to see if it will reduce. So that means we need to try to factor the numerator. And this numerator, we can take out a GCF. Can take out a 3 times x minus 6 over x plus 7 times x minus 6. And we are able to reduce. The x minus 6 will divide out. So our answer is 3 over x plus 7. I'm sorry, I ran out of room a little bit there. So 3 over x plus 7 is your answer. For this problem, we're going to have to factor the denominator in that second fraction before we can find our LCD. This is a difference of squares, so it has x plus 5, x minus 5. So we do have something in common in our denominators. So we'll build up our LCD. You have to have every type of factor that you have, take it from the fraction where it occurs the most. So for x plus 5s, I only have it once in one fraction. So I will need that. For the x minus 5s, it occurs once here and once here. So we will only need it once. It's the most from any one fraction. So this means that we are going to need to work on the first fraction. We will multiply it by x plus 5 over x plus 5. The second fraction is good. It already has the denominator we want. So I'm going to go ahead and just keep this denominator. On our first numerator, this is going to be a FOIL. So our first term's x times x is x squared. We'll go ahead and combine outside and inside. All right, 5x on the outside plus 5x on the inside is 10x. And last, plus 25. All right, that takes care of the first numerator. Don't lose your minus here. It goes with that second numerator. So that will be minus 100. Now we can combine our constants there. To get minus 75. And we have to see if that trinomial will factor. I believe it will with 15 and 5. So we want a plus 15 and a minus 5. So that should work. And then we are able to divide out the x minus 5. So our answer is x plus 15 over x plus 5. You cannot take anything else out. You cannot cross off the x's, or you cannot do 5 into 15 because of the sign in between. Those pieces have to stay together. For our next problem, we do need to factor the second fraction, the denominator. So we can do a GCF. We can take out a 2, and that leaves us x plus y. All right, so these denominators do have something in common. They have the x plus y. So let's go ahead and build our common denominator. Right, for the 2's, we're going to need 1, 2. This one has none, this one has 1. That has the most. And we're going to need 1 copy of x plus y. That's the most in either one fraction. So the second fraction is actually okay. We will just use this factor denominator now. Right, the first fraction is going to need a factor of 2. Right, so we're going to keep this denominator, a 2 and an x plus y. We'll multiply out that numerator, so 4x minus 10y. On the second fraction, this minus is going to affect both of those numerators. So minus 3x plus 7y. And we can combine our like terms here. 4x minus 3x is 1x. And our y terms minus 3y. That is not going to factor. So there is nothing that will reduce on this problem. We're going to just do this problem and then a couple of the negative identical ones from the back of this page in your note template. I think I had too many examples in there, so we're not going to do all of them. Right, so first of all, we have to factor these denominators to figure out our common denominator. So on the first one, that's a trinomial, different signs, split the x's, and how about 7 and 4? For the second one, we can take out a GCF, we can take a 2, and that leaves x minus 7. So we will build our common denominator from these factors. First, for our monomials, we will need the 2. For x plus 4, we only have 1 copy. We will need that. And for the x minus 7s, we have 1 in this fraction and 1 in this fraction. You take it from the one with the most. So they're tied. So we just take 1 copy. Right, so for our first fraction, the piece that we're going to need to put on there is the 2. And for the second one, we're going to need to put the x plus 4 to get that common denominator. Right, now we will keep the common denominator. So a 2, an x plus 4, an x minus 7. Your order here doesn't matter for the x minus 7, x plus 4. Right. Simplify on that numerator, so 2 times 5 is 10. For the other one, it's a positive 7. It's going to distribute. So plus 7x plus 28. And we can combine our constants. So we get 7x plus 38. If you wrote 38 plus 7x, that's fine. To think about reducing, for your numerator, your only choice is to try a GCF, but there is no GCF, so there's nothing else you can do on this problem. If you have the negative identicals or the opposites for denominators, you can actually use either one of those for the common denominator. There's no reason to have to use both. Right? I usually pick the one that looks like it's in the right order instead of backwards. But it doesn't matter. You could choose either one. So I'm going to choose x minus 2 for my common denominator. That means I need to work on the other one. Remember to change it before we factored out a negative 1 when we were going to simplify. But here, because we need to work on numerator and denominator, we will multiply numerator and denominator by negative 1. That way we're really multiplying just by 1 if we do it numerator and denominator. And you can go through the steps and check. This will give us negative 2 plus x and that's going to be the same as x minus 2. Right, so we will keep our common denominator, which is going to be x minus 2. Our first numerator is fine. We'll bring that down. For the second one, we have negative 3 here times negative 1 will give us positive 3. Don't forget that sign. And then we can combine. So we have x minus 1 over x minus 2. There's nothing else you can do. There's no factoring you can do. You're not allowed to take a piece off because of these signs in between. So these problems are actually easy if you recognize opposites, because you can make them match just by multiplying by a negative 1 over negative 1. So notice this problem also has the negative identicals or opposites for denominators. They're both minus, one's turned around, and if you check close, positive x, negative 7, positive 7. So you can force those to match if you multiply by a negative 1. So we can use either one for our common denominator. I'm going to go ahead and use the x minus 7, which means my first fraction is okay. I need to multiply the other one by negative 1 over negative 1. So this makes negative 7 and plus x, which is actually the same. Now I'm going to keep my common denominator of x minus 7. The first numerator is good. Second one will multiply to get minus 3. And then we can combine. So we have 4x plus 3 over x minus 7.